Now we want to discuss here the butt joint in the case of thin plate. Later on we'll discuss the butt joint in the case of thick plate. So let's consider here the plate 1 and plate 2, and we want to make the welding joint at edge to edge. So when we want to make a welding joint over edge to edge, in that case you have to bring the torch near the gap and you have to fill the filler material. If you fill the filler material here, so it is a fusion of the parent material as well as the filler material will fill in this gap. So this gap is filled with the fusion of parent material and the filler material. At the same time, there is a reinforcement is developed over this area. So somewhat the reinforcement is done over this area. So this entire space is filled with the filler material. So some sort of reinforcement is developed over the bottom as well as over the top. Here also we have reinforcement is done. This reinforcement is for filler material. The enlarged view of this figure is shown here. We have throat height equal to H and we have reinforcement height is equal to HR. This bottom portion and the top portion is called as reinforcement. So this hatch area, which one is called as reinforcement, after you do the welding you can remove this, but it will going to develop the stress concentration. So you have to grind off this. So if you remove the reinforcement, then the resisting area will be equal to this hatch area, which has a height equal to H and the length equal to L. Because this time the gap is such sufficient that the filler and the parent material will fuse inside the gap. So this area is called as the resisting area, is H multiplied by L. But if we make a single V groove, in that case we have to make a groove here initially, and then the filler material will fill the gap between the two plate 1 and 2. So this one is plate 1 and plate 2. But again the reinforcement will be developed here, but the reinforcement will be done only on the top side. You don't have to grind it from the bottom, you have to only grind it from the top. So this one is the idea about the butt joint in the case of thin plate. But suppose you have to weld the two thick plate as shown in this figure, then you have to make the double V groove or double U groove. The filler material will be filled inside the U shape on the top as well as the U shape in the bottom. So in this space we will find here the fusion of the parent material as well as electrode. So this one is fusion and the electrode. So this one is the fusion of parent material and the filler, but this gap is small here, so filler material will not enter into this small space. So near the throat section we will find the fusion of parent material. So this part of fusion, which one is of parent material plus filler or electrode, and bottom part of the filler and the parent material will give the resistance to the external forces. So this time we have H, which one is effective throat is H1 plus H2. Now this space here will not participate in the resistance, that is the fusion of only parent material. So the effective height in this case is H1 plus H2. If H prime here is a thickness of the plate, then we have H prime will be equal to H1 plus H2 plus distance D. So we can very well calculate H as H1 plus H2, or we can calculate it as H prime minus D. So while going for the thick plate, you don't have to consider the area formed at the throat. You have to neglect that area. In this case, we have area will be equal to H multiplied by L. H is called as effective throat height. Whereas in the case of the butt joint, our effective area is equal to H multiplied by L. So we'll consider two cases. One is for thin plate and one is for thick plate. And we'll consider two modes of failure. One is the tensile mode, in which the force F is perpendicular to the given area, and second case we have force is parallel to the given area. Now this time we'll design the butt joint. Butt joint is basically used to join the two plate along the edges. This one is plate 1 and this one is plate 2. These two plates are joined at the edges. For this one we have to make a groove and then you have to carry out the welding. Two types of loading is possible. One is called as tensile loading. In the case of tensile loading, the force F will act perpendicular to the throat area. So this one is representing the throat height equal to H and the length of weld equal to L. Some crowning is done here, that is called as reinforcement. So the direction of the force is perpendicular to the throat area, which is H multiplied by L. In that case, the butt joint will fail under the tensile loading, and the corresponding the normal stress will produce, where normal stress is sigma, may be tensile or compressive depending upon the direction of force, is given as F divided by H multiplied by L, where H is called as the weld throat and L is called as length of the weld. So the crown portion that you visualize here is called as reinforcement. That is, this crown portion that you visualize is a reinforcement. So while calculating the area, only the weld throat is considered, that is the height H is considered. The height of the reinforcement is not considered. Here the height of the reinforcement will be equal to HR. Once we do the welding, there is a stress concentration is formed at a point A. But during the welding, the reinforcement is normally grinded off as it crosses the stress concentration. Reinforcement is done during the welding to compensate the strength of the weld in the presence of the weld defects. So the reinforcement is desirable, but it varies somewhat and thus produces the stress concentration at point A. If the fatigue load exists, it's a good practice to grind or machine off the reinforcement. So while taking the grinding or machining of the reinforcement, you have to take the care that it should flush with the weld throat height is equal to H. But if the undercut is done, that is the reinforcement is removed and some undercut is done, then the actual area resisting will be going to decrease. So this figure again represents here the reinforcement with height equal to HR, but if we have improper selection of the welding parameters, then there is an undercut. During the undercut, the height of the weld throat will going to decrease. So this time we have effective weld throat will be H minus T, and therefore we have sigma this time will be equal to F divided by the effective height this time is H minus D multiplied by length of weld equal to L. So if there is an undercut, the effective height of the throat will decrease and you have to take the effect of decrease in the height as H minus D, and then you can calculate the value of sigma. The allowable stress in the case of butt joint is based on ultimate strength. So sigma allowable is always equal to SUT divided by the factor of safety, and this value of sigma should always less than sigma allowable. If in the numerical there is not mention of the undercut, in that case the throat area will be H multiplied by L, and if we have undercut, in that case the throat area will be H minus D multiplied by L. So this time the throat area is perpendicular to the direction of the force F, and therefore we have tensile loading. If the direction of force is reverse, it's a compressive loading, but the value of the stress, that is the magnitude of the stress, is remain same as F upon H into L. The butt joint can also fail in the shear loading if the direction of force F and the throat area are parallel to each other. In that case it is a shear loading, and when we have a shear loading, in that case the shear stress is produced. The value of the shear stress tau is same as equal to force divided by throat area H multiplied by L. But normally the butt joint is used for the tensile loading, is very rarely used in the case of shear loading. So by default you have to always consider tensile loading. So we have clearly two distinctions here. In the first case here we have a throat area is perpendicular to the direction of force F, and in second case, that is the shear loading, the throat area is parallel to the direction of force. So in the case of tensile loading, if the no undercut is done, then the normal stress is produced, that is the tensile stress is produced, is given by F upon H into L. And if the undercut is done, in that case we have normal stress produced will be equal to F upon H minus D, where D represents here the depth of undercut and L represent here the length of weld. So here D represents the depth of cut. But it is maybe possible here that the welding can be done for two unequal thickness here. In that case we have to select the minimum value of the thickness. So the thickness of the plate here is T, as well as the thickness of this plate is also equal to T. So in this case we have thickness of the plate T is same as equal to H. T is the thickness is same as equal to the throat height H. Now this one is also a groove butt joint, but we have two different thickness of the plate. One is T1 and one is T2. In that case, you have to select the minimum value of T1 and T2 as the throat thickness. So this joint is also fail under the tension. This time we have to select the value of H as a minimum value of T1 or T2. And therefore we have throat area will be equal to H multiplied by L, which one is the area of the throat. And the normal stress is produced sigma is equal to F divided by area A. As we have discussed initially, in the case of thick plate, we are going to use the double V joint. Here total thickness equal to T is consist of one V groove which has a height equal to H1. Then V of groove is equal to H2, and we'll find here this I have shown with a very negligible area because this part is filled with the parent material and this part is filled with the parent material plus electrode. So only you have to consider the height H1 plus H2. So in the case of double groove joint, we have H is equal to H1 plus H2, which is same as equal to the thickness of the plate minus the throat thickness, that equal to D. And if you apply the force F, then you can calculate the tensile stress sigma, which is same as equal to F divided by area. In this case, you have to take the area as same as equal to H multiplied by L. So these are the cases that we required in the case of groove butt joint. The permissible tensile stress in a butt weld joint is 85 Newton per mm square. He says tensile, so failure you have to consider under the tension. With a weld length of 50 mm, determine the maximum allowable force can be applied to the plate. We have to consider two cases. In the first case, we have single butt joint with the plate thickness equal to 12 mm. And in second case, we have double groove butt joint of plate thickness equal to 20 mm and the distance between the two groove is equal to 8 mm. So let's solve here the first part, in which we have a single butt joint having a plate thickness equal to 12, weld length equal to 50 and the value of sigma is equal to 85. So consider here a single butt joint and we have thickness is same as equal to H is equal to 12 mm. Length is equal to 50 and sigma is equal to 85. Let's say F1 is the required force that we want to find out, for which the welding will stand. So this failure is due to tension. So we have F1 is equal to the normal stress sigma multiplied by resisting area, which is H multiplied by L. Normal stress is equal to 85, that is Newton per mm square, and H into L is also mm square, so mm square will get cancelled. We have thickness is equal to 12, that is the same as throat height 12, and we have length of weld is equal to 50. So this answer will be Newton. So single butt joint will withstand a force approximately equal to 51,000 Newton or very close to 51 kilonewton. This is the approximate answer I am giving you. In the second part, you have to consider the double groove butt joint and the plate thickness equal to 20 mm. So we have value of T is equal to 20 mm and the distance between the two groove, that is a groove 1 and groove 2, that this distance is D, which is equal to 8 mm. Suppose this double groove joint withstand a force equal to F2. In this case, we have effective throat height is H is equal to T minus D, which is same as equal to H1 plus H2. So we have T is equal to 20 minus D is equal to 8. So we have effective height is same as equal to 12 mm. So that was the same as the previous value, that equal to H. So we are getting the same force here. Let's calculate here. So we have F2 is equal to sigma multiplied by throat area, that equal to H into L. We have sigma is same as equal to 85, throat is equal to 12, length of weld is equal to 50. So this answer is also equal to 51 kilonewton. Both these single butt joint as well as double butt joint will withstand a force equal to 51 kilonewton. Two plates are joined by means of single V butt joint having a thickness of the throat is equal to 200 mm. What will be the percentage change in the tensile strength, that is the value of F1 and F2 of butt joint, if the plates are joined by means of double V butt joint having the throat thickness at the top is equal to 200 and the bottom thickness, that is H1 and H2, is given for double V groove joint. Other parameters remain changed. It means that the value of sigma and the value of length of weld are remain same. So let's consider here we have a single V butt joint, and let's say the resisting force is equal to F1 in the case of single butt joint. Our failure is tensile, so we have F1 is equal to sigma multiplied by height h multiplied by length L. In the first case, for single V butt joint, the thickness of the throat is 200, so we have value of h is equal to 200. So we can calculate F1 as 200 times sigma multiplied by length L. It is the weld length. In the second case, we have to use the double V butt joint, and the throat thickness at the top, that is H1 value, is given as 200 mm and the bottom as H2 is equal to 150 mm. We know that the value of D will not contribute in the resisting area, so we have effective weight is H is equal to H1 plus H2, where we have H1 is equal to 200, H2 is equal to 150, that equal to 350 mm. So let's say F2 is the force resisted in the case of double V groove joint. So we have F2 again equal to sigma, which is remains same in both cases. Length of weld is also remains same, multiplied by h. This time you have to use the value of h equal to 350. So we have F2 equal to 350 multiplied by sigma multiplied by L. What we are interested to know, the percentage change in the tensile strength of a butt joint, that is F1, if the plates are joined by means of double V. So percentage change here will be F2 is a higher value. So we have F2 minus F1. You have to compare with the original value F1 and you have to multiply by 100. So sigma into L will be get cancelled. We have 350 minus 200 divided by 200 and is again multiplied by 100. So we have 150 divided by 200 is close to 75%. So it will increase by 75%. So choice A is correct. Hence for large thickness we have to use the double V groove butt joint, and for small thickness you have to use the single V butt joint. A butt weld joint is developed on a steel plate having a yield and the ultimate tensile strength of 500 and 700. The design of a butt joint in tension is based on the tensile strength and not on ultimate strength. The thickness of the plate is 8 mm and the width is equal to 20 mm. Width you have to take as same is equal to the length of weld. Improper selection of the welding parameter cause an undercut of 3 mm depth along the weld. The maximum transverse tensile load. The butt joint in the tension is based on the tensile strength. So value of sigma is same as equal to SYT is equal to 500 megapascal. We have given the thickness of the plate, that is value of H is equal to 8 mm and the undercut D is equal to 3 mm and the length is same as the width is equal to 20 mm. So in this case we have area, that is this area, which one is the effective area of the throat, will be equal to H minus D, that is the undercut, multiplied by the length of weld equal to L. So we have maximum force that can be resisted by a butt will be equal to area multiplied by sigma value. Area is same as H minus D multiplied by L multiplied by sigma, that equal to SYT. Here the value of H is equal to 8, D is equal to 3, length of weld equal to 20 and value of sigma is SYT is equal to 500. Solve this, you will get the value of Fmax. So value of Fmax is close to 50,000 Newton. That is equal to 50 kilonewton. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.